Hi everyone, today we're going to solve this problem, that is LeetCode 1937, maximum number of points with cost. So you are given an m cross n integer matrix, 0 indexed, starting with 0 points. You want to maximize the number of points you can get from the matrix. Okay, so we have a matrix that is a rectangular matrix m cross n and m cross n size ratio, and you are going to, so you have a points, you have a point system and you want to increase them. Obviously you want to increase them, and starting with 0 points, you don't have initialized points with you. You're starting with the 0 points and you want to maximize the number of points from the matrix. Now let's see what is the catch, what are the operations that we have to perform in order to do that. To gain points, you must pick one cell in each row. Okay, so in each row we have to pick a cell, then uh okay, so the points will be the value at that cell. However, you will lose points if you pick a cell too far from the cell that you picked in the previous row. For every coordinate, every two adjacent rows, that is, okay, these are the two adjacent rows, that is this row and this row. Let's take an example. Picking cell coordinates at a different column and a different column will subtract the absolute difference between the column numbers. Okay, makes sense. Return the number of maximum number of points you can achieve. Okay, and absolute is that either the value is negative or positive. It will just give you the difference between the two values that you provide, that is c1 and c2. So for example, in this case, if you see that we have 1 2 3, and this is the solution, by the way, that in this row you will pick the maximum value as 3. Okay, and in this row the maximum value, see, it's not like you're picking the maximum value in row, because if you think about it, there could be a way where, if you pick the maximum value in every row, but in the next row when you are going to pick the maximum value, that maximum value is way too far, right? Okay, let me give you an example what I want to say. So let's say that rather 3, um we have 1 here and we have 3, and 5 is sitting somewhere here, so we definitely will pick 3 here because that is the maximum value in the first row. But in the second row, if you pick, so there is 5 and there is 4, if you pick 5 here, right, then the maximum, so if you pick 5, so for example, let me take this and do it in a better way. What I want to tell you that, so because some of you might have this thinking that if we take the maximum value in each row, then it might solve the problem. But I can prove you that is not the case. The reason is, let's say for an example, at this position you don't have 1, you have 5. At this position you have 1, and at this position you have 5. Okay, if you pick the first value, that is 3, okay, then from the first row you will pick the value as 3. From the second row, if you pick the value as, so 3 value, and let me give the column names, rows, and let's begin. So from 3, okay, very nice. Now in the second operation you will pick the value as, obviously because this is the maximum value, right, the 5, so you will be very much intrigued to pick the 5 value. So if you do that, the previous one that we have is 3, this one, and now we pick this value, that is 5. 3 plus 5 minus, so what was the formula, try to remember, recall it. So it was the points that we want to add, right, picking cells at this coordinate, so we are adding these points, and then we are subtracting the absolute value of their columns, which means that the absolute value of their columns is going to be 2 and 0. So that is 2 minus 0, which is equal to 3 plus 5 is 8, minus of 2, now this is going to be 6. But if I don't pick the maximum value, that is 5, and let's say right now we don't have 5, we have 4, that is the second maximum value. So this is not a good path. So I'll do the other way, and that is to pick the 4 value. So if we go to 3 plus 4 minus the absolute value, that is of 2 comma 2, and now this is going to be 7 minus of 0, and now we have 7 value, which is highest. So if you see that it's not about picking the maximum value in each row, because there is a possibility that the maximum value as compared to the previous value that you have selected is way far from the value that you have selected already, and the absolute difference of their columns would be greater. If a negative, you know, value is greater in the equation, then it's going to be impacting, and it can be greater in a way that the value which we will get from picking a value that is not the maximum but relatively closer to the previous value that we have picked would be, that value would be lower than that, you know, picking the maximum value. So that's why this solution will fail. Now what I can see about it is that it's not like picking the maximum value, it's not a greedy solution. So if it is not a greedy solution, then the next thing that you can identify is that it's more about, you know, like at every cell there is a possibility that you can pick this value, and then you have to make a way out that should I pick this one, should I go this way, should I go this way, and which one should I select, right? It's very much like that we are trying to check all the possibilities, that is all the cells, and with every cell we are trying to make a decision which one to pick, which cell is responsible for giving us the maximum value, right? In that, you know, scenario, it is kind of evident that it's the problem is more about using the concept of dynamic programmings, because we have to travel all way. Obviously we cannot do it like for every cell we will make a travel and then see, because that will be way too expensive and way too time consuming. What we can do is, for example, in case where we have a, you know, like a cell that is r I comma j, let's say. So we have a, you know, we select a cell that is I comma j. Okay, now I have two options. The number one option is, actually I have three candidates. Okay, so if I select any of the cell in the first one, then I have three candidates. So candidate number one is that in the left, in the top, you know, a0, or let me just say that in the sub array of a0, not 0 actually, it's a I minus 1 comma 0 up till a I minus 1 comma j minus 1. Either I take the left, you know, in the topmost row. For example, if this is the I comma jth cell, then I have an option to take a value from this subarray. Okay, or this is the candidate 1 by the way, or the candidate 2 is that I took the rightmost value, that is the ai minus 1 j. This is one way, because in this case we don't have an absolute difference, right? Because it's in the same column and the absolute difference was going to be 0. So we don't have we don't have anything to subtract from our points. And the candidate 3 is just the, you know, reverse of the candidate 1, that is the right subarray of the previous row, which means a I minus 1 from j plus 1 to a I minus 1 to n. Okay, so this is the, for example, this is candidate 1, this is candidate 2, and this is candidate 3. Now these are the options that at each cell, you know, we will have these values which one to take. And what are these values, by the way? These are nothing but, you know, the point differences that we'll get. If I take the left subarray, that is candidate 1, then I'll have the benefit, you know, I'll have the advantage points with these many points. If I, you know, I'll get the best point in this subarray. If I take the candidate 2, then I'll get the best point in this subarray, and then if I take the candidate 3, then I'll get the best points from this subarray, right subarray. Out of this, the maximum one is something that I'm going to select. So if we minimize the problem, right, if we start from, let's say, the first element for I, sorry, not for I, it's actually for 0 comma 0, that is 1. So if we start from here, do we have anything at top? No, we do not. Do we have anything at this side? No, we do not. So we'll not take anything. Similarly for second one, do we have anything at top? No, we do not. Do we have anything at this side? Yes, we do, but um, it's not. So see, you need to have a previous row in order to make those exchange, and you cannot because you don't have a previous row in this case. So first row will be as it is. Let's move on to further row, and that is the first one. By the way, this first iteration that I'm doing is left to right. Now if we take the one, this 1 comma 0 element, can I take anything from the top? Yes. If I take the candidate, sorry, if let's do it, one by one. If I take the candidate one, that is the left subarray, and if we are following left to right, that means we are just taking candidate one, and also we can consider candidate two as well, but candidate three would not be there. Why? Because that is right to left direction, right? And we are just considering left to right for now. So that's why we will ignore candidate 3 and we'll just take candidate 1 and candidate 2 in consideration. So if I say that for 1, can I take anything from this side? From the left side? No, we cannot. Why? Because there is no elements, right? But from the top, yes, I can take, and that will be +1. Now let's move on to 5. For 5, can I take anything from the top? Yes, I can, and that will be +2. Can I take anything from the left side, left subarray? So this is the subarray, by the way, and this subarray we only have one element. Yes, I can take, but see, if you take any element, any exchange, the point difference benefit that you will definitely get something, and that is 1. But you are going to a different column, right? It's not the same column, which means that you are going to a column that is see, this is the best, this subarray will have the best point option available for us. And how we will get that? The best option will be in the leftmost element. Okay, so leftmost element say that, okay, I have a +1 advantage, you can have a +1 advantage from me, but the absolute difference has to be subtracted because this is a different column. So it would not be +1, it would be 0 actually, +0. And obviously the maximum value is +2, so we'll go with +2. In this case, we can take +3 from here, like from the top. Obviously there is no absolute difference of the column, so that is nothing is subtracted. But in this case we can take +1, right? By why? Because we have to subtract the difference of their columns, right? We are taking it from the left side, and the maximum would be 3, so we'll take 3. Now the points, now we need to decide, the point values. So for 1, that is obviously going to be, +1, so it's going to be 2. For 5, it's going to be 7. For 1 and 3, obviously 3 is the maximum one, so it's going to be 4. So now we have these values here with us, the new values to be honest. And now let's move to the 3 element. So we can have +2 from there, and we can have +0. So I'll say +2 is maximum, let's take it this one. Now similarly we can have +7 or we can have +1, and similarly we can either have yes, so in this way we can either have +4 or we can, so obviously the maximum one is, we can remove the smaller one, so maximum one is +7. We will take the +7, but we have to subtract, so it will be +6. Now this is going to be 5, this is going to be 6, and this is going to be, so max 6 is the maximum one, so this is going to be 7. Now you have these values with you, and you can make a check because this is a left to right direction, right? So you can make a check which one is the maximum. So from left to right, we found out that in the last row we found 7 as the maximum. And how do we got 7? So we took 6 from here, right? What do we mean by taking it from the left element? Which means, so this left element, so this element says what is the maximum points that I can have from the left, from my previous row, left subarray, and the topmost element in the previous row, in the same column, previous row element. Okay, so it will compare these two things, candidate 1 and candidate 3. So this element says that this is the maximum value in this part. if you take full consideration, right? Which means that if this element says that this is the maximum value, then this element will say this is the maximum value in this part, isn't it? So if rather than checking this manually, should I not ask this element that, hey dude, you have the answer to this sub array, can you just give me that? And this will say, yeah, sure, this is 6 actually. 6 is the advantage you can take. And that's how we'll come to know that this is a dynamic programming problem, because we can take reference of the point exchange from the previous element in the same row, which will give us the answer to the maximum points we can have from the previous row left subarray. Okay, so we take 5, which means we take, we go this direction, which means we take the left subarray part. And in this element, in this part, what is the maximum one, the maximum points that we can have? So we have to decide it in this part now. So we can take either 7 or 2. From 7, how do we get 7? We take this value, which means that in this case 2, 5 and 1, this is going to give us the maximum values, and that is something 2, 5, 7, 8, and this is going to be 7 answer. But this is for only left to right. For left to right, we will get 7 as the max. But obviously this is not just about being left to right. The problem can also be looked from right to left. Not just can also be, it must be looked from right to left. The reason being, right now we are not taking consideration of the right subarray, right? Which is not right. We should be taking consideration of it. So let's take the consideration of right to left, that is C2 and C3 candidate. So let's see what value do we get. Obviously for these elements we won't get any value, so we'll leave the first row as it is. So let's start from this value now. If I take the first value, it will be plus 3, and if I take this from this side, it will be 0. So obviously I'll take the plus 3. If I take it from the top, it will be plus 2, and if I take it from this side, that is the right side. And what do we mean by right side? It's the right subarray, right? And how can I know the maximum value? From this element. So this element will give us that value, and that is plus 3, but it's a different column, so we have to subtract, the difference of the absolute difference of the column, that is the difference between the columns, and that is going to be 2. And from this side I can take plus 1, or I can take plus 1 from this side as well, and that's it. Now if you try to compute, so plus 1 same value, so that is going to be 2, that is 2 is the value, 7, and then this is going to be 4 because we have selected 3. Now in this case, when you are at 1, either you can take plus 4 from this side, or you can take 0, and now you can take plus 3 from this side, or you can take plus 7 from the top. Or now in this case, either you can take plus 6 from the from the left side, or you can take plus 2. Now in this case, plus 4, this will be 5, and this one will be 8, this one will be 9. Okay, now let's remove all of that, and let's see the maximum value at the bottom that we can have, following the path. What would it be? 985. So maximum value is 9, so 9 is the answer. When we follow the path right to left, we get 9. When we follow the path left to right, we get 7. And obviously we have to take the max, so max would be right to left. Following the path right to left, we get 9. How do we get it? So we have to take it from, if you remember, well, I have to add the things again, but if you remember, for this part, we have to take the value from this face, right? Which means that we relied on the left subarray. In the previous row, the right subarray. And in this part, if you remember, we took the value from this guy, which means that we relied on that. I think it was plus 2 and plus 2 here as well. But if you follow the path, it'll make sense that if you take the value from this guy, actually if you take the value from this guy as well, it is fine, right? That's why we have plus 2 on both sides. So if you go this direction or this direction, every direction is fine. But right now, just for the sake of this diagram and the coloring, I'll say that we go to this direction, and we took the value from the right subarray, which means this guy, we asked this guy what is the maximum value in your subarray, and this returned us plus 2, which means we go to this direction. So see, this is how this problem is going to be. Now let's move towards the code part. So, okay. So first of all, we need to have total number of rows, that is going to be points dot length. And then we have to have columns, points 0, length. Now we need to have, see, we have to store the maximum points, right? I'll create a variable to store it, and the initial value will be 0 because that suggested the starting with 0 points. And then we need a long row max. Now what is this variable? This variable means maximum number of, or we say like the maximum we can, it's not actually the maximum points, it's the maximum points difference that we can achieve from the current row. Okay, now let's move to another variable, and this time we have to set up the, see, we have to keep consideration of the previous row and the current row, which means we need an array as the previous row, that is going to be new long, and the size would also be equal to columns, the number of columns that we have. And similarly we have a current row variable that is equal to new long, again the size has to be equal to columns. So first part is, let's initialize, because as I said earlier that we cannot process this row, the reason being we don't have a previous row for it, so that's why we'll initialize the previous row now with the first row of the matrix. So I'll say that for int j is equal to 0, j less than calls, j plus plus, and now the previous row j is equal to points, that is 0th row and jth column. Okay, now we will start processing from the second or first index row. So I'll say int j is equal to 0, not actually j, because this time we'll be iterating on rows. Okay, so it has to be I and less than rows. And see, we won't be processing the first row, so we can start from the, we won't be processing the 0th row, so we can start from the first row. And I plus plus. Now the first thing is, so current row, well, let's start with the first part, and that is calculate the row max, the maximum, variable maximum points difference that we can get by following the left to right direction. Okay, so if I do that, I'll say for int j is equal to 0, j is less than columns, j plus plus, and if the j is equal to 0, that means this is the first element. For the first element, right, for 1, we do not have any element on the left side, so we cannot take the difference from the left subarray in the previous row, which means that the row max has to be initialized here with yeah, so the row max has to be initialized here with the previous row, jth column. Okay, which means that if you see, this is the current row, if you see that this is the current row and this is the previous row, so obviously the previous row element, that is going to be this one. Else, if that is not the case, then we need to find the maximum. The maximum would be now row max, row max value would be, now we need to select the maximum. Okay, so maximum between which one? So either we select the maximum from the previous row, that is the previous row same element, that is previous row jth same column, or we select the row max, that is the previous value that we have. If we are updating this value, then it means we do have a previous value of the row max, that is row max minus 1. And when we do this computation then current row jth value would be equal to, now it has to be max of, not max of, because that will not be done in the first part, because this row max variable will be the maximum in any of the case, so we can just initialize it. Now we will calculate for right to left direction. Okay, right to left direction, and it's actually very much similar logic, although some changes are there. For example, j, it has to be calls minus 1, this value has to be greater than 0, and it should be decrementing. Now j would not be equal to 0, it would be actually calls minus 1, the first element or the last element of the row, and that is the last element. Okay, and this one is equal to, I mean, that's fine, we can say previous row. And now what we will do is that either it's the previous row above element or row max minus 1. Why we are subtracting 1? Because that is the, that says that we are taking an element from the previous column. I mean, in the right to left direction, that is the next column, that is x plus 1 column. If the current column is x, then it will be x plus 1 column. And obviously there's a difference, right? So we have to subtract it. And in this way, and right now there is a catch. So current row was initialized here, right? Current row didn't had any value earlier. So we initializing it. That's why we just initialize with row max. But in this case, that is not the same case, because current row is initialized in the left to right direction. So in right to left, we need to have a max check. If current row is already maxed out, I don't want to take a value from the row max variable, right? If not, only then take the value from the row max variable. Now the second part is, so now we have the current row prepared, but what does this current row has? What it actually has is the differences. Okay, the points differences, from the maximum point differences that we can get, right? So now what I'll do is, I'll say now we have the maximum point difference that the each cell of the current row can offer. Therefore, applying it to the cells values. Now, when we are applying it, we have to just start a loop, and it can be, in either of the direction, because it doesn't matter. We are just applying, filling the values, because we know what is the maximum point difference that we can get from either following the left or right direction. And now we are just applying. So I'll say that current row j is incremented with points I j, right? Now at the last part, the previous row, the current row is going to be our previous row. So previous row will be changed to the current row, and the current row has to be initialized. It has to be initialized. So I'll say current row is equal to new long n. Okay, so now the processing should be completed. We'll move ahead and see, now you have the last row. Okay, in the last row, this is our processing, that in the current row, that is up till the last row, we will have all the maximum values with the point difference and the points. Now in this phase, what we'll do is we'll have the maximum value that we can have. In the current row, we do have that information, but we need to extract it. So I'll say j is less than calls j plus plus, and the variable that we had earlier, if you remember, the maximum points, max points, this variable. So we'll use it here. I'll say max points is equal to math.max, take the max points as it is, or just use the current row jth column. That's like saying that when you are in this row, you are just selecting the maximum value. So you select the 9 from here, and if you remember earlier we had 7. Either if the cells we some of the cell has this value or 7, and we just selected the maximum one. So same case what we are doing here, and then we will simply return max points. Now let me just check if, okay, it's a long, so let's see if this solution will work. Okay, so it should not be n, obviously. It should be calls, that is the columns. Okay, we do not have a good result as of now. Okay, see, the current row will have 0 value, but the previous row will have the information of the current row. So we'll say previous row, because we are initializing the current row. That's why after exiting this processing loop, in this case we will have the current row to be as initialized with 0 values, so that is not going to be helpful for us, and we need the value. So we will have the previous row, current row data will be in the previous row, so that's why we are using previous row here. So let's try submitting it, and it is passed. Okay, and let's talk about the time complexity of the solution. So if you see that right now we are just initializing it, and in this case it will take order of n time, or let me just give you an collected time. So time would be order of n. So first of all, n meanings uh, the number of columns, right? So we iterate over all the rows, which means the it's actually m. Then m meaning number of rows, or I can say r multiplied by, for each row we make a